Okay, this is the P1 paper from January 2024. It's question number 8, and as we can see by looking at this is going to be a Radians question. So let's jump straight into it. Let's have a look at the information they've given me over here. So they've said angle AOB is 0.8 radians, so that's 0.8 radians. They've told me that the arc length CD, this big arc here, is equal to 9 meters, and they've told me that DA to AO is in the ratio 3 to 5. So this to this is in the ratio 3 to 5. It doesn't mean that they're 3 and 5, obviously. They're just in those ratios. One way I might say that is that that's 3/8 and that's 5/8 of DO or OD, however you want to say it. And then let's have a look at part A. Part A says show that AO is 7.03. So I'm going to be trying to work out this length here. But I don't have any information about this small sector in here. I don't have any information about that one yet. So what I'm going to have to do is talk about this sector, where I've got 9 and I've got 0.8. From that, what I'll be able to do is I'll be able to work out that length, and then I'll be able to say AO is 5/8 of that, from what I can see that from the diagram here. So let's make this clear to the examiner what we're doing. I might actually just quickly draw that sector out. Yes, ODC, just really quickly for that one there. I'm talking about for this sector here then. We know that this is 9 and we know this is 0.8 here, if that's the sector ODC. And then I'm simply going to use my formula for the length of an arc. So L equals R theta. So 9 is equal to 0.8 times R. So I can work out what R is here. R is going to be 9 divided by 0.8, which is 11.25 centimeters. Remembering that that is OD, and what I wanted was AO. And so AO is 5/8 of OD, which is 5/8 of 11.25, which then will work out to be, and thankfully they've already told me the answer, so that's really helpful, 7.03 meters for the first one. So now what I'm going to do maybe is to get rid of these bits here and just on my diagram put that I now know that this is 7.03 meters. And what does part B say? Part B says, can we find the perimeter of the platform in meters, correct to 3 significant figures. I said centimeters there. No, just centimeters back there. Let's just change that. Sorry, apologies. That should have been meters. Yeah, so part B, find the perimeter of the platform. So if I'm looking for the perimeter of the platform, that's going to be this length, this length, this length, and then all of that arc length around there. So we can do different things for those. Obviously, we already know that CD is 9 meters. Here, if I want to work out AD, I'm just going to do the 11.25 that we had before minus the 7.03, which will give me that one. So then the main thing I need to do is to work out that arc length there, and that arc length there is always R theta. What I need to do is I need to find what that angle there is. Well, that angle there is going to be 2 pi minus 0.8, isn't it? 360 minus the angle, but we're working in radians, so 2 pi minus 0.8. So what I just need to do is be careful and make it really clear to the examiner what I'm doing. There's lots of different steps I can do here. So to say what I'm doing, so I'm going to say, first of all, the perimeter is equal to, and just tell him all those things. So it's AD, it's the arc AEB, go back and look at the diagram, and then it's just BC and DC all added together. So I'll go with AD and BC first. AD, which is equal to BC, is just equal to, so you could do 3/8 of 11.25, or you could do 11.25 minus 7.03. It doesn't matter which way round. Let's do it as 3/8 of 11.25. So that works out to be 4.22 meters, or you could do it the way I said previously, is just subtract that from 7.03. 11.25 minus 7.03 would give us the same answer. Let's do the arc. So the arc AEB, L is equal to r theta. So L is going to be equal to, the radius is 7.03. And theta here, in fact, I'm going to leave it as 2 pi minus 0.8 rather than even working out what that is and stick all that into the calculator. Just makes it clear to the examiner as to where I'm getting that from. That works out to be 38.5 meters. And so the perimeter is going to be equal to 4.22 plus 38.5 plus 4.22 again, plus 9, in whichever way round we want to do those. If I was doing it in the same order as before, actually, let's just not confuse the examiner. Then I'm going to say we started off with 9 plus that, plus 4.22. But it doesn't make any difference, the answer. The answer is going to work out to be 56.0 meters. With all of these questions, go back and just check each time. For the perimeter, they want it to 3 significant figures, and that is 56.0 to 3 significant figures. Be careful, make sure you're using exact numbers all the way through. And then part C says, right, can you now find the total area of the platform, given the answer in meters squared, and to the nearest whole number this time. So the area of this platform is going to be the area of that sector there, which is just going to be half r squared theta, where that's my theta and my r will be the 11.25 we had previously. And then the other area is going to be the area of this sector here, done along the major arc. So it's still going to be half r squared theta, but it's going to be a half. R is going to be 7.03 for that one, and theta is going to be 2 pi minus 0.8. So half r squared theta plus half r squared theta. Just keep it nice and clear for the examiner. Just make it nice and clear for the examiner. So I'm going to say area is equal to, and I'm going to say the area, you don't need to do this particularly, but I just want to make it clear, sector OCD plus the area, and again, sector OAEB. Even if I didn't put that in, when I do half r squared theta plus half r squared theta, as long as I make it clear what values I'm using, just in case I've made any mistakes previously, this is half 11.25 squared times 0.8. It also does give me the opportunity to just check again there. I have got the right r with the right theta, not making any mistakes here. And then half the 7.03 squared for that one. And again, I'm going to leave this as 2 pi minus 0.8. You could put the value in if you wanted, perhaps being overly fussy there. And then just jump straight to the answer now. Work all that out, see what it works out to be. Apparently, it works out to be 186 square meters. And I would very strongly suggest when you do one of these Radians question, just at the end, go back and make sure, because it's 3, 3, and 3 marks here. Make sure you are doing these things correct to the nearest significant figures or anything else like that. They were kind on that first one because they told me what to make it there, but otherwise we don't want to be losing silly marks on a question. Hopefully, if the diagram's not too bad, and I don't think this diagram is too bad for this one, they could have had way worse ones, but this one's not too difficult at all. Hopefully that will make sense to you all.